Get you guys in a better place. Hello, my fellow YouTubers. This is Roy back again. I'm tethered. What's going on, my YouTubers? This is Roy back again. What's going on, Justin? What's up, my mole? My bro over there. Let's look down this sucker here. What's going on, Jason, man? What's up? Jason in the house. That's a long plank to walk right there. Looks like a laser light. What's up, Team 7 in the house? Yeah, it's not easy to do, I'll tell you. It's not been the easiest. So right now, the way this is set up is, let me take this apart. Alrighty. So there's going to be some changes that I'm going to do. And through a lot of testing I did today, that I can see I started in a good direction, but there's major things I did wrong. So before I go to the negative and the wrong stuff, let's look and see what I did do. Alrighty. So I got a copper shaft. Let me see, how do I get that out? I don't want to break it. Well, I got a coil in there. And the coil is taking up about that much space. And I should have at least 6 inches, because when I did the math and I measured from where the handle is and where the shaft is, it's 4 inches. So I should have an 8-inch throw. So my throw is wrong, and also I'm using 1/2 inch. So I'm going to go and use a bigger shaft. So we're going to use a bigger shaft because a 1/2 inch shaft is not enough mass, which is pretty, took me a little while in my testing to kind of realize that I'm looking at all this, how big it is, how heavy it is, and it just didn't make sense. But at least I got it hitting pretty good. Volts, okay? Got it hooked up to 24 volts, and I got the coil in here. Now remember, this coil in here is concealed in there, so it's coming out of this coil is getting trapped into the iron casing and getting a sword back into the process. So as I come out, what we're going to do is I'm going to tap the coil, and when this shaft is sitting straight out perpendicular, we're going to come over about to the 1 o'clock position. Once it gets just like that, we're going to go ahead and have the coil pull the wheel in, and as it comes in, I'll be letting go, and then we'll see it want to pull itself back out. The reason I'm not going to keep doing it right now is because I need to have a spring that I'm going to put on the back of here. And the spring is going to push the shaft and push this copper shaft as well back out. So when this is compressing inward, it's going to compress the spring. When this starts going outward, the spring will be pushing it out, as well as it'll be pushing the shaft out longer, so there's a good travel space in between this copper shaft, copper shaft, and the half-inch there. So we'll go ahead and get this to about 1 o'clock position. So I'll go ahead and just touch it. You can see it pulls real good. And this setup right here is really good because now I'm going to be able to turn the wheel and not use any of the components down bottom other than generating power right here. So we'll be, let me just get it turning, and then I'll just hit it at the right spot. I missed my opportunity there. Yeah, see, I don't want to mess this up, but this shaft needs to be pushed back out, and it needs to be variable like that for this to all work because of the traveling distance that's going in the coil. There's a lot to this to make this work, but I've been thinking about this one for years, and I'm not saying Ed did this. I'm doing this, and it makes sense. I think another pole over here. So on this stroke, this half a stroke, this one, all it has to do is as this turns fast, basically it's gonna take very little power to pull because of the mass turning fast. So how can I do this? I'm gonna have to put you guys down for a second. And I'm gonna put some kind of damn spring on this. Once I put a spring on that, I'll hook it to here, and then I'll be able to turn the wheel fast, and you'll be able to see what I mean by hand. It's pretty damn cool. And there's a lot of pull strength, but that's the half-inch. I won't drop you guys. All right, so I'm gonna throw a little, see what do I have? Some type of bungee cord or something. Hang on tight, guys. Alrighty. Look what I found out in the dark. Little thing of bungee cords. That'll hold that in. Got a little tiny one. Alright, so we're gonna take that, we're gonna just hook that up. Where's a good safe place? Right there. You guys seen that? So Hey, what's up, Adam? All right, so we got a bungee cord set up. So this, oh wait, hold on. That shaft's gonna come outside of that. That's not gonna work. Hold on. That's, I can't have it in there. I pulled the shaft back. Holy shit. Let me get it set a little bit better. I can't believe that worked. All right. Shaft's going forward. Let's give it a whirl. There's your little spring. Little spring action. Just got to keep coming forward. So as I turn the wheel, I just got to time it. Uh-oh. See, it came out. I got to pay attention. I can't fool this thing up. But this son of a bitch works good. Uh-oh. Back in action. Guys, get back on the thing here so I can rehook it. Using the handle like a baron, basically. Not pulling it back further enough. So I don't want to ruin my setup I have right now. But I can still hook the coil up, watch. There you go, that was coil action. You ready again? Here's some coil action right here. It's gonna be the coil pulling it. That's the coil. Let me get it just started. So you guys get the point, right? So with my experiments today that I messed with this box, what I've realized and learned is I need bigger mass for a slug. The bigger the slug, and the travel distance for this should be double of what my distance is from my shaft to how far the circumference is of the diameter of what this handle is doing. Pretty cool stuff. So I measured it out from here to here was 4 inches. Shaft here, throw is 8 inches. That means I should have at least a 7-inch coil, which I only have a 4-inch coil in there. So I'd done things wrong. But the cool thing is I learned a lot today of what to do and what not to do. But I got through the learning curve, I think, on this because pull the shaft out. There we go. I'm gonna knock this box out in front. Watch this. So I got a wooden box. Got a wooden box. Look at this thing turning. The handle's the sleeve. Here's my coil. 16 gauge wire. So it's 0.8 ohms. So if you divide your voltage, 24 volts, and divide it by 8 ohms, it's 30 amps. So I can feel it's really warm or hot, actually. So the coil design is wrong too. So with having more throw, that's 3 inches. If having more distance in here and I'm going to use, I'm going to get some magnetic 12 gauge wire, and we'll get it so it doesn't get hot. That's the goal. It shouldn't get hot at all. So I'll figure out and do the math on how much wire I need to put on there. No, I haven't seen. Hey, Scott in the house. My boy. Winding vortex coils. Lord and Kay in the house. No, I'll look them up. I'll look them up. But the key is, according to my buddy Scott there, made by one man, give a shout out to. He's a cylinder master. And I had to have a long chat with him on it. And basically, I designed it wrong, but at least the concept is working. And we'll put the right coil wire in here, and we'll back those 30 amps down to some decent. So we're going to put in, say, 12 gauge wire. We know 12 gauge wire is good with 20 amps because in your house you got a 20 amp circuit breaker. So we're going to wind it up so it holds a good 15 amps, I guess. 12 amps, 15 amps. Got all the boys popping in tonight. Woo-hoo, NASCAR. So, yeah, got the coil. Pretty nice setup. Easy to build. I got to set the spring up. Very important to have the spring. There's a lot of a lot of things, you guys, in setting up cylinder coils. You'd be surprised. It's really not that simple. You gotta know a lot of stuff, and you gotta pay attention to a lot of stuff. That's the key too. Let me see here. You put your back on here, so I'm gonna set this back up. All right. There you go. Got two hands now. There we go. Like my aluminum experiments. Love my aluminum experiments. Yeah. Alrighty. See the coil pulling out? So, yeah, there's a lot more to do with it. I can't do much with it now. It's got to get set up right. Hopefully you guys like it. Yeah, pretty much. And so we'll be using this like it was a crank handle or a crank. What's going on, Adam? So pretty much you have a crank here, and this coil here will be one of two because I'm going to put one on this side. So on the back swing, the this one over here will be pulling, and on this front swing, this one will be pulling. And I'm going to use the cam clover leaves as a cam. And the clover leaves are going to, hold on guys. The clover leaves are going to be the switching device. And that, as the wheel turns, it'll be telling the coil to turn on. So it's better to be using it. So the clover leaves will be the cam, yeah. So basically, it'll be activating each side. And so basically, if you think about this, it's about conservation, because the top will be turning the wheel, and because of the mass of the wheel, once it gets going and you pull it at the right time, say between 2 o'clock and 5 o'clock towards you, if perpendicular straight out, and say, no, you were at, say, 10 o'clock, and pull it from 10 o'clock, say, to from 7 o'clock, 10 o'clock to 7 o'clock, or even 11 o'clock to 7 o'clock. So you don't have to pull it that long, but you would just pull it, and as the wheel turns faster, the faster it goes, the less of a pull you have to get, just like Tesla's coil, to where you're just pushing the swing at the right moment and you're not putting a lot of energy into it. So the same concept is what I'm looking to do here. Once the wheel's turning fast, I don't have to put a lot of energy into it. So I should be able to set up my I keep wanting to think variac, but my commutator, and have it to where I start off, say, with 24 volts, and I get it going. Once it gets to a certain RPM, then I can back down the voltage, which should slow the wheel down. The voltage, which should be the speed as well. So it'll slow the wheel down or go faster. But it'll be a tug of war between both sides. And then the bottom, I already know what I can do out of these PMH coils, so it's wide open what I do all the way around them and how much power we can get back in. And then the goal would be is the power that comes in, have it be the power as a self-exciter to the coils above it, and to get this thing turning on its own would be a major thing with no induced power, just self-exciting power. Well, you do have resonant frequencies with the wheel. One is based on how many poles you have around here, which we have 24, and the speed that you make a contact or something in front of the pole as a reference point. You'd have to have something as a reference, and you turn it and have your speed, and there's your frequency. So, but it's times, 24 times for one complete circle. Pretty cool stuff. So basically, we could be in the Schumann resonance with this in the anywhere ranging from 7.83 up to, say, 40 hertz. 7.83 hertz to 40 hertz. Because there is a fluctuation in the Schumann resonance, and I think I can't wait to the summer equinox, because I'm gonna do some more studies with ground studies, and I believe that there's a pressure buildup there. There's some type of energy transformation or gathered or more is gathered up or compressed, should I say? So. Yeah, so the next equinox in summer, the one we just had for spring, I was doing some tests in the ground, and I'm just amazed because it's higher in some days and don't do anything other days. So it's not like anything invented here, but when there's changes in season with the equinox, something is going on. There's a more flashpoint. Now, for instance, Schumann resonance. Now, Schumann resonance, they say, is calculating how many lightning strikes there are worldwide, and that would be the Schumann resonance in a hertz. So how does that actually formulate there? Riddle that to me. Because is all those thousands of lightning strikes happening per second all around the place, are they like in the bell area, like they're in the bell, they're in the space to where there's airspace, so that's where from the ground would be the ball in the middle, and the upper stratosphere would be the shell of the bell, and you're ringing that and getting that frequency. So and the lightning strike seems to be a reaction due to obviously a buildup and transfer or release of matter, dust particles that gets caught up and swept up and blown up and gets thrown into a source of a lot of energy. And there's your storms, and then there's your difference. So you guys, hopefully you enjoy the video. Leave your comments. Can't wait to get this set up right so we could actually be able to control the speed, get it turning, and then start putting, I guess what I'm going to do is these PMHs, I'm going to go around the whole wheel. So in front of every set of magnets, there's going to be a PMH sitting right in front of it all the way around. And we're going to have some of these coils. We're going to do a bunch of experiments because you got coils around the magnets, which we know are like a PMH, and these permanent magnets become super strength field magnets all of a sudden. They also can flip their poles. The PMHs are super strong magnets, and you can wind different coils to get different effects out of them. So like this is 22 gauge wire, and this has a lot of resistance, and you're going to get higher voltages coming out. But when you go up in the voltage, you just got to balance out what you're going into out of the circuitry out of this. We'll get into circuitry down the road. This is my little shavings collector from making this drill and all this stuff and getting that set up. So guys, leave your comments. Hopefully you enjoy. Give a shout out to everybody watching, and